Okay, we're going to run through the answers here for exit slip 111. And we're supposed to identify if the statement is true or false, and you can draw a number line to help you if you'd wish. So I've done that on number 1. So go ahead and take the time right now. Go ahead and draw that so you know that's an option. And I started with 0 and branched out and went to -5 over here and a +5 over here. You wouldn't necessarily have to make it just like that, just as long as you can get 3 and -5 in there. And I'm going to go ahead and mark where 3 is and where -5 is on the number line. And our first question says 3 is greater than -5. A lot of us wouldn't need the number line for this. We know that positive numbers are greater than negative numbers. So in this case, it is true. And again, on the number line, you can see that everything to the right here is bigger as we're going larger, and then as we go negative, remember it gets smaller. Even with a bigger number, -5 here, even if it's negative, it's actually smaller because it's farther away from 0. So that is a true statement. Number 2, every integer is a positive number. So we have to know what the definition is of the word integer. And we know an integer is a whole number or its opposite. So numbers like 0, 1, 2, 3, 4, 5, and then their opposites, which would be like -1 is the opposite of 1, -2 is the opposite of 2, and 3 and -3, and so on. So is every integer, is it a positive number? That would be false, because we know it's those counting numbers or whole numbers and they're opposite. So that would be a false statement. Okay, every integer is definitely not positive. They can be negative. Okay. Number 3, there is a whole number between 1/3 and 3/4. We should know, again, a definition that a whole number is are the counting numbers and 0. So 0 is included in there. So we're looking, are there any numbers like 0, 1, 2, 3, 4, 5, etc. that would fall between 1/3 and 3/4? And we know there wouldn't be. There would just be fractions between fractions in there. But these are both less than 1. They're between 0 and 1. So there is no whole number in between there. So that would be false. Number 4, a negative number is always less than a positive number. Again, a lot of us probably don't need a number line here. We know negatives are less. So again, that would be true. A negative number is always less than a positive number. Okay, if you have negative, if you're thinking of money, we know we owe someone money. Okay, we're in the negative. We don't have money. We owe. We're in debt. Whereas when you're in the positive, then you have money, and obviously that's more than owing somebody money, which would be negative. Moving on here, number 5, order these fractions from least to greatest. Again, with fractions, there's many ways we could do this. Some people use that number line to help you. And it might help you there. You could use common denominators. Some people can turn them into decimals. You could think of them as percents if you're ready for that. I'm just going to talk about the common denominator method here. So I'm going to change these and having a common denominator. And I'm looking at the 10 and the 4 and the 5 and the 2. And if you think about multiples and known facts, I can get all of these to 20. And I could list multiples to do that. I could count by 10s, 10, 20. I could count by 4s, I'd get to 20. I could count by 5s, I can get to 20. I can count by 2s, I can get to 20. So I'm going to make these into 20ths. So remember, whatever I do to the bottom, I must do to the top. So in 9/20ths, I could change that to, or 9/10ths, excuse me, I could change that to 18/20ths. If I double the bottom to get it to 20, I must double the 9 to get it to 18. On 3/4, I'm going to take that 4, and I'm going to take it times 5 to get it to 20. So I must take the 3 times 5 also, and that would give me 15/20ths. And again, I could write up here what I'm taking it time, multiplying it by. 9/10ths, I'm taking it times 2 halves. Remember, that equals 1. Everything times 1 is itself with that identity property, so the value stays the same. 3/4, I'm multiplying it by 5/5 to get it to 20. On 4/5, I got to take this 5 down here in the denominator and take it times 4. So I got to take the top times 4, so I'm multiplying that fraction times 4/4, and I get 16/20ths. And then 1/2 I know is the same as 10/20ths. And those are equivalent. So if I can get that common denominator, guys, it gets pretty easy to list these from least to greatest because I have the same size pieces now. So in this case, 10/20 is the smallest, and that is 1/2. So let's write the original back in there. There's the smallest. Okay, and I'm going to cross that off to know that I've already used it. After 10/20, it looks like 15/20 is the next, and I know that is 3/4. I'm going to get that into simplest form and get it back to its original form. And then 16/20 is a little bit bigger, so that's 4/5. It is a little bit larger. And then the last one, 18/20, which is 9/10. And a lot of kids struggle with these because they see, when they're looking at the original fractions, guys, they see that the denominator and numerator are only one apart. Okay, so some kids, if they don't have understanding of fractions, they could think these are possibly the same size. But we know we have different size pieces. And the bigger the denominator, the smaller the piece. So we're in tenths here. Those are smaller pieces than fifths, fourths, etc. So if I'm missing one and only have 9 out of 10, you're missing a smaller chunk. So that means 9/10 is larger. So it is larger than 4/5. Some people can think of these as percents. Some people just know 1/2 is 50%. 3/4 is 75%. 4/5 is 80%. 9/10 is 90%. So you could order them if you're able to do those type things. You could also turn them into decimals. There are a lot of different ways to think about them. You could draw pictures using circles and get them into equal pieces, and you'd be able to shade them and tell those things. But a lot of times, common denominators, if you can find one, that's an easy way to do it too. Okay. And the last one, number 6, Trent says that there are no numbers between 2/3 and 2/4. Why might he think that? And what would you tell him? Well, Trent might think, if he's thinking this, he's thinking, well, maybe they're both, the numerators are both 2, so how do you get something between 2 and 2? And he's not thinking the relationship between the numerators and the denominators there. Again, if you know percents and things, and some of you will get to know and do these things, you know 2/4 is 1/2, that's like 50%, and 2/3 is 66 and 2/3%. And so then you can know there's definitely numbers between 50% and 66 and 2/3%. But in that, some of you maybe can't do that right now, which is fine. But if they say there's no numbers, we should know, guys, that there are always fractions between fractions. Okay, and I'm going to write that. There are always fractions between fractions. Okay, we can always zoom in and find smaller fractions with smaller pieces and get things that fall in between fractions, even when they get really small. Okay? So here are your answers for exit slip 111. So make sure you finish getting this stuff written if you have not.